Today I am going to talk about Sama's circular model on real life. The Sama circular model is a quite new technique. It is a univariate forecasting technique introduced in 2018. The SCM can be considered as a time domain and frequency domain model. The SCM is the improved version of the circular model of Konarasinghe 2016. So first we'll see what is the circular model. The circular model is developed based on physics, pure maths and statistics. That means theory of uniform circular motion from physics, Fourier transformation from pure maths and least square regression from statistics. As you know, the Fourier transformation has two versions. They are discrete version and continuous version. This is the discrete version. According to De Moivre's theorem, this exponential part can be given as a summation of two trigonometric functions. Joseph Fourier has used this one in his discrete version and write the real valued function as a summation of trigonometric series. In short, what Fourier said is a wave, regular or irregular, can be splitted into packets of waves. The Fourier transformation is incorporated to a uniform circular motion of a particle in a horizontal circle. In usual notation, if a particle is moving in a horizontal circle, omega is the angular speed. So omega is rate of change of the angle with respect to time. By using the integration, we get t equal theta over omega. If the particle takes capital T seconds to complete one cycle, it is known as the period of oscillation. So one complete cycle angle is 2 pi radians. Then t equal 2 pi over omega. I mean from this equation to this one. Then make omega the subject. So omega is 2 pi over t. Period of oscillation is equal to the time between two peaks or troughs of a sine or cosine function. From my point of view, when I was doing my PhD, I thought if a wave has simple f peaks in capital N observations, then the period of oscillation can be given as total number of periods over total number of peaks. That is capital N over simple f. So I modified omega as 2 pi n over f. So then omega become 2 pi f over n. Using this equation, I calculated the omega. Then the discrete version of the Fourier transformation is modified. Actually speaking, I theoretically proved this one. So what my point of view was, a real valued function, a continuous random variable at time t, can be given as a summation of trigonometric functions plus a random error component. Fourier transformation, of course, a mathematical function. That means it doesn't have a random error component. But the real life data following wave-like patterns, they have a random error. So this is the circular model. These are the model assumptions. For example, this is the time series plot of monthly returns of a company in Sri Lankan share market. You can see it follows a wave-like pattern. It is an irregular wave. So peaks are these. You can count the peaks easily. In this particular example, in 200 observations, there were 45 peaks. So omega was calculated, and after calculating omega, we can use any software, Minitab, MATLAB or any other one to fit the model, to test the model. Before I will come to the topic, Sama circular model. The circular model was highly successful in capturing seasonal and cyclical pattern of a series. But it has one weakness. It is not applicable for series with trend component. So Konarasinghe 2018, I used the differencing technique to mitigate the limitation of the circular model. So in usual notation, first difference is yt minus 1 and second difference and dth order difference and so on. So the modified circular model or the renamed Sama circular model is this. What it says is value of a random variable at time t can be expressed as past lags. D can be anything, maybe the first lag, second lag and so on, and the trigonometric series plus the random error component. This Sama circular model has few important features compared to the existing statistical models. You know, the time series data comprises several components: trend, seasonal variation, cyclical variation and irregular variation. Due to that, these series follow irregular wave-like patterns. Such patterns are common in every field: meteorology, agriculture, finance, econ and everything. So, modeling this kind of data were immense important in real-life situation. The decomposition technique and the ARIMA or SARIMA are the widely applied methods for forecasting such a series. They were indeed highly successful methods, yet these techniques have some weaknesses. One thing is, both methods, decomposition or ARIMA-SARIMA, are unable to capture the cyclical variation. Also, previous researchers have shown that the forecast of SARIMA or ARIMA do not follow the patterns of actual data. And sometimes these wave-like patterns may have more than one seasonal variation as well as more than one cyclical variation. So even if the ARIMA and decomposition technique are capable in capturing seasonal variations, they are unable to capture several such variations. When compared to them, the Sama circular model, it was successful in all those ways. I mean, it is capable in capturing seasonal, cyclical, trend, as well as it is capable in separating the several seasonal variations or several cyclical variations. As I said, it is a new model introduced in 2018. So during this short period, it has been applied and successful in these fields: finance, hotel and travel, econ, gender studies and meteorology. Some studies were conducted by me and some by other researchers. I will show you one example how to apply this Sama circular model. This is the female unemployment of Australia from 2009 to 2018. You can see it follows an irregular wave-like pattern with non-linear trends. To fit the Sama circular model, first we keep the trend aside. That means we have to eliminate the trend temporarily. For that we take the differencing. Here the first differencing and second differencing series. You can see they don't have any trend. They show irregular wave-like patterns. So, when testing the model, first calculate the angular speed. That is by counting the number of peaks and using the formula I showed you earlier. Here I am showing you how to do it in Minitab. The same procedure is valid in other software as well, unless you are writing a program in MATLAB or some other programming language. So omega is calculated. Omega is 2 pi simple f over capital N. Once when the omega is calculated, we make, see omega is 1.2799. If the data set has 200 observations, make a column of t 1 to 200, then multiply omega and t, make omega t column. After that, using the calc of the Minitab, obtain sin omega t, sin 2 omega t, and so on. As I mentioned in the model, k is a real number. It can be a decimal or whole number, but as a rule of thumb, I use k equal 1 to 6 as the first step. That means sin omega series, sin omega t to sin 6 omega t, and cos omega t to cos 6 omega t. This is the difference between Sama circular model and other statistical techniques. Here these derived trigonometric series become the independent variable. Once when they are obtained, and the multiple regression as usual way, taking the first difference series as y and x1 to x12, that means 12 dependent variables, run the regression. So get the regression output and see what are the significant trigonometric series. Here this is the regression output. You can see these are the p-values. None of the p-values are less than 0.05. That means none of these trigonometric functions are significant. So what to do? That means the method does not work with the first difference. So let's start with the second difference. Same procedure is used. If you are using Minitab, you have to make these series again, but if you are using MATLAB or any other programming language, you can write a program and go ahead. So whatever the way, it is not difficult. So after several tries, this is the best fitting model I got. Here you can see yt is a function of first lag variable, second lag variable, and 3 trigonometric functions. So in this model, I tested the model validation and verification criterion. They all were satisfied. And these are the 3 trigonometric functions. Period of oscillations of these were 4 months, 13 and 7 months respectively. 4 and 7 months signify the seasonal variation in female unemployment, whereas the 13 months shows the cyclical variation. That's what I said. There are 2 seasonal patterns and 1 cyclical pattern. Without any effort, easily we find how the data behave. So these are the plots of these trigonometric function. Period of oscillation is found simply counting the number of peaks in one complete cycle. Here are some more examples. Sama circular model on tourism, forecasting tourism arrivals to Sri Lanka. You can see all these 3 show irregular wave-like patterns. So these are the fitted models. Some models contain only 1 trigonometric series, some have several trigonometric series. And this is forecasting consumer price index of India. So this also shows irregular wave-like pattern. After several tests, I found here the first lag variable, that means first difference series worked. So it also contained 2 trigonometric functions. These are few of the references in applying Sama circular model. You can go to Institute of Mathematics and Management website and see my profile, or you can get my Google profile to see more articles on Sama circular model applications. What is expected from you is apply them and see whether there are any weaknesses, or see whether it is possible to improve the technique, because it is a new technique. As researchers, as scientists, we must always try to do something new, must contribute something to the world. I am not saying that this is the best model, but up to now, with real life data applications, it has been found that the Sama circular model is superior to the existing techniques. Even the American Statistical Association last year agreed that the SEM is superior to ARIMA and decomposition and other techniques in real life applications. So it may not true always. Apply them, and even if it is the best, there may be some possible improvements. So contribute. I am always willing to help you. Finally, I would say practice makes perfect. The Institute of Mathematics and Management believe determine, dedicate and done. If you want to do something, you have to determine, you have to dedicate, and then only you can do it. So I take this opportunity to thank Dr. Flora Charles and the team of Eurasia for inviting me for this great opportunity. Actually speaking, I am not new to Eurasia. I have been working with Eurasia over the last years. I will be working with Eurasia in future. So thank you again for giving me this opportunity. And I thank you also for listening and sharing knowledge. Have a good day.